The universe isn't just vast and empty, it's full of places that would kill you in ways you can't imagine. From glass rain at supersonic speeds to magnetic fields that could atomize you from solar systems away. I'm breaking down the 8 most disturbing cosmic locations ranked from unsettling to nightmarish, starting with one that doesn't kill you, which somehow makes it worse: the void. Imagine staring into the night sky and seeing almost nothing. No stars, no galaxies, no light except a handful of dim specks scattered across an ocean of blackness. That's the reality for any civilization unlucky enough to exist in the Bode's void, and it's exactly as disturbing as it sounds. The Bode's void is a supervoid in space discovered in 1981, sitting roughly 700 million light years from Earth in the constellation Bode's. It stretches 330 million light years across. To put that in perspective, the distance from Earth to our nearest large galaxy, Andromeda, is 2.5 million light years. That entire journey covers about 1% of the void's diameter. And here's where it gets weird. This region should contain around 2,000 galaxies based on the average density of the universe. It contains 60. That's 97% fewer galaxies than expected. The void is so empty that astronomer Greg Aldering calculated that if the Milky Way had formed in its center, we wouldn't have discovered other galaxies existed until the 1960s. Edwin Hubble proved other galaxies existed in the 1920s. The void would have delayed that discovery by 40 years. Those 60 galaxies that do exist aren't randomly scattered. They're arranged in a bizarre tube-shaped filament running through the void's center, like a cosmic drainpipe. Scientists believe the void formed when smaller voids merged together over billions of years, like soap bubbles combining into one massive empty pocket. Quantum fluctuations in the early universe created slight density differences. Gravity pulled matter into filaments and walls, and the Bode's void is what got left behind, a region where almost everything got pulled away. But here's the thing, this isn't a place that burns you alive or crushes you with gravity. It's pure existential dread. A civilization at the void center would look up and see almost nothing. No neighboring galaxies visible to the naked eye, no cosmic neighbors. Just trillions of cubic light years of darkness and isolation, the ultimate cosmic loneliness. And nobody there would even know what they were missing. At least in the void, you'd have a planet under your feet. Our next location doesn't even give you that. Hell next door. Venus is the most disturbing planet in our solar system, and not because it's some distant nightmare world. It's disturbing because it's our closest neighbor. At its nearest approach, Venus sits just 38 million kilometers from Earth. Mars gets more attention, but Venus is literally next door, and it's an absolute hellscape. The surface temperature averages 464 degrees Celsius. That's 872 degrees Fahrenheit, hot enough to melt lead, zinc, and tin. And here's the kicker. Venus is the hottest planet in the solar system despite being farther from the sun than Mercury. Mercury should be hotter. It's not. Venus has a runaway greenhouse effect so severe that it traps heat more efficiently than being closest to the sun ever could. The atmosphere is 96.5% carbon dioxide with clouds made of sulfuric acid. The greenhouse effect maintains that temperature everywhere, all the time. Day, night, equator, poles, doesn't matter. Uniformly deadly. But the temperature isn't even the worst part. The atmospheric pressure at the surface is 92 atmospheres. That's 9.3 megapascals. To experience that pressure on Earth, you'd need to dive 900 meters underwater. Imagine 92 cars stacked on every square inch of your body. The atmosphere is so dense, about 65 kilograms per cubic meter, that it doesn't feel like air anymore. It's closer to wading through a fluid. Standing on Venus would feel like drowning in a furnace while being crushed by a hydraulic press. The Soviet Union's Venera landers are the only spacecraft to ever photograph Venus's surface, and they died fast. The longest any probe survived was less than 2 hours before being simultaneously crushed and cooked into failure. Vega 2 measured 91 atmospheres of pressure and 736 Kelvin before going silent. And get this, the upper atmospheres rotate 60 times faster than the planet's surface, a phenomenon called superrotation that scientists still don't fully understand. Meanwhile, a Venusian day is 243 Earth days, which is actually longer than its year at 225 Earth days. The planet spins so slowly and backward that the sun rises in the west and sets in the east. Venus is 95% of Earth's radius and 81.5% of Earth's mass. It's our twin planet, almost identical in size and composition. And that's what makes it genuinely terrifying. This isn't some alien gas giant billions of miles away. This is what can happen to an Earth-like world when a greenhouse effect goes wrong. Our sister planet is a vision of hell, and it's close enough to see in the evening sky with your naked eyes. If you think that's bad, wait until you meet Jupiter's moon that never stops exploding. Torture moon. Jupiter's moon. Io is the most volcanically active body in the entire solar system, and calling it a hellscape is an understatement. This moon makes Venus look peaceful. At least Venus sits still while it kills you. Io is being actively tortured to death by gravity, and it's been happening for over 4 billion years. Here's the thing, Io sits about 422,000 kilometers from Jupiter, roughly the same distance as our moon sits from Earth. But Jupiter is 318 times more massive than Earth, and that creates a gravitational nightmare. Europa and Ganymede, two of Jupiter's other moons, create an orbital resonance with Io that locks it into an elliptical orbit. Every 42 hours, as Io completes one lap around Jupiter, the planet's gravity squeezes and stretches the moon like a stress ball. The solid surface bulges up and down by 100 meters. Imagine the ground beneath your feet rising and falling by the height of a 30-story building twice a day. That constant flexing generates enormous internal heat, and that heat has to go somewhere. It goes out through 400 active volcanoes. The volcanic eruptions on Io are staggering. Plumes shoot 500 kilometers above the surface. The International Space Station orbits Earth at just 400 kilometers, so these eruptions are launching material higher than the ISS orbits. Loki Patera is a lava lake covering 21,000 square kilometers, larger than the entire state of Maryland. In 2025, NASA's Juno mission recorded the most powerful volcanic eruption ever documented on Io. A hotspot larger than Lake Superior, producing 6 times the combined energy output of every power plant on Earth. Eruption temperatures reach 1,700 degrees Celsius. Those are lava temperatures not seen on Earth for over 2 billion years, back when our planet was still geologically violent. But wait, it gets worse. Io sits inside Jupiter's intense radiation belts. The radiation exposure is 3,600 rem per day. That's 3.6 million times Earth's daily background radiation. A human standing on Io would receive a fatal radiation dose within minutes. That's equivalent to about 3.6 million chest X-rays in a single day. And because Io is constantly spewing charged particles from its volcanoes, it acts as an electrical generator, creating a 3 million ampere current that flows along magnetic field lines to Jupiter's poles. The moon generates a 400,000 volt potential across itself, pumping 2 trillion watts into Jupiter's aurora system. Io has the lowest water content of any known object in the solar system. It's been outgassing for its entire existence, losing 94 to 99% of its total sulfur. The moon is literally being cooked from the inside out and has been since the solar system formed. At least Io stays in one place. The next planet has weather that moves at 7 times the speed of sound. Glass Nightmare. HD 189733b sits 64.5 light years away in the constellation Vulpecula, and from a distance it looks beautiful. Deep cobalt blue, almost identical to Earth when photographed from space. That resemblance is a lie. The blue doesn't come from oceans. It comes from clouds of molten glass. The planet is a hot Jupiter, about 1.13 times Jupiter's mass, but slightly larger in radius, orbiting its star at just 0.03 astronomical units. That's 3% of the Earth-Sun distance. 1 full year on HD 189733b takes 2.2 Earth days. The atmospheric temperature exceeds 1,000 degrees Celsius, and the planet is tidally locked with a permanent dayside temperature around 1,200 Kelvin. But here's where it gets horrifying. The winds reach 8,700 kilometers per hour. That's 5,400 miles per hour, 7 times the speed of sound. 36 times faster than a Category 5 hurricane. Those beautiful blue clouds are made of magnesium silicate particles, essentially molten glass measuring 0.01 to 0.1 micrometers. At those temperatures, the silicate stays airborne as microscopic droplets. Gravity pulls them downward like rain, but the supersonic winds hurl those glass shards sideways in a planet-wide horizontal storm. Imagine being sandblasted by molten glass moving at Mach 7. Death by 1,000 cuts doesn't cover it. You'd be shredded into a fine mist before you could process what was happening. And in 2024, the James Webb Space Telescope detected hydrogen sulfide in the atmosphere. That's the molecule responsible for the smell of rotten eggs. The planet doesn't just kill you with supersonic glass storms, it stinks while doing it. The violence is driven by extreme atmospheric circulation that wraps the entire planet, creating a temperature hotspot offset 30 degrees east of the substellar point. The day side is so hot that molecules break apart into individual atoms. Spectroscopic observations show sodium, calcium, and other elements scattered throughout the atmosphere, completely vaporized. The Hubble Space Telescope has been watching this planet since its discovery in 2005, and observations show the winds could circumnavigate the entire planet in roughly an hour. NASA released artist renderings showing what the planet might look like up close, and even in illustrations, it looks terrifying. A blue marble wrapped in bands of horizontal glass storm moving faster than bullets. HD 189 733b is one of the closest and best studied exoplanets, which means we know exactly how it would kill you. Scientists have mapped the temperature distribution, measured the wind speeds, and confirmed the glass composition. There's no mystery here, just physics and chemistry creating a nightmare world that happens to look like home from a distance. But if you think raining glass is bad, the next planet rains something even heavier. Iron rain. WASP 76b is located 637 light years away in the constellation Pisces, and it's where the concept of weather breaks down completely. This is an ultra-hot Jupiter, 0.92 Jupiter masses but bloated to 1.8, 3 times Jupiter's radius. It's so puffed up from heat that it has 83% more volume despite weighing less. And the reason it's bloated becomes very clear when you look at the temperatures. The permanent day side reaches 2,500 Kelvin. That's 2,227 degrees Celsius or 4,040 degrees Fahrenheit. Iron melts at 1,538 degrees Celsius. On the day side of WASP 76b, temperatures exceed 2,400 degrees, which means iron doesn't just melt. It vaporizes into gas. The atmosphere on the day side is filled with iron vapor, along with vaporized sodium, magnesium, calcium, manganese, potassium, and titanium oxide. Molecules get ripped apart into individual atoms. The air is literally made of metal, but here's where it gets insane. The planet is tidally locked with winds reaching 18,000 kilometers per hour, about 5 kilometers per second. Those winds carry the iron vapor from the scorching day side to the cooler night side, where temperatures drop to around 1,500 degrees Celsius. That's just below iron's condensation point. The iron vapor cools, condenses into liquid metal droplets, and rains down. It rains molten iron on WASP 76b, droplets of liquid metal falling from the sky at 1,500 degrees. Scientists confirmed this using the Very Large Telescope's ESPRESSO instrument. They detected iron vapor at the evening terminator, the line where day transitions to night. But when they looked at the morning terminator, the iron vapor was completely absent. It had all rained out overnight. The smoking gun for iron rain is that the metal disappears from the atmosphere on the night side because it literally falls out of the sky. Even calling the night side cooler is absurd. At 1,500 degrees Celsius, it's still hot enough to melt gold at 1,064 degrees and copper at 1,085 degrees. And in 2024, the European Space Agency's Cheops satellite detected hints of a rainbow-like glory effect in the planet's atmosphere. If confirmed, it would be the first glory ever seen outside our solar system, formed in clouds of vaporized metal, a rainbow made of iron vapor. WASP 76b orbits 10 times closer to its star than Mercury orbits our sun, completing a full year in 1.81 Earth days. The day-night temperature difference is roughly 1,000 degrees Celsius, driving the atmospheric circulation that creates the iron rain cycle. One hemisphere perpetually bakes under vaporized metal skies. The other sits in eternal night, showered in molten iron. And that's just a planet. The next object is a star that's barely holding itself together, the Magnetar, SGR 1806-20 is a dead star 20 kilometers across, roughly the size of Manhattan, sitting 50,000 light years away in the constellation Sagittarius. It's a magnetar, which means it's a neutron star with a magnetic field so powerful it defies comprehension. Most neutron stars have magnetic fields around 1 trillion Gauss. SGR 1806-20's field exceeds 1 quadrillion Gauss. That's 1 million billion times stronger than Earth's magnetic field. And on December 27, 2004, it proved exactly how dangerous that makes it. At 2130 UTC SGR 1806-2, O experienced a starquake. A crack formed in the neutron star's crust, just centimeters wide. But at nuclear density, even a tiny fracture is catastrophic. The star released more energy in 1/10 of a second than the sun emits in 150,000 to 250,000 years. The total energy output was 2 times 10 to the 46th ergs at a power of roughly 10 to the 40th watts. It was 100 times more powerful than any other magnetoflare ever recorded. And the blast was so intense it saturated every X-ray and gamma ray detector on every satellite in Earth's orbit. The flare didn't just reach Earth, it affected Earth. From 50,000 light years away, the explosion briefly expanded our ionosphere, increasing night-side ionization to daytime levels. The CHOMP satellite detected the magnetar's 7.5-second rotation period modulated into our planet's magnetic field. Reports came in of fishermen in the Arctic witnessing a sudden aurora at the exact moment of impact. Victoria Caspi of McGill University said it plainly. Magnetars are the only deep space objects to directly affect Earth. This thing reached across the galaxy and touched our planet. The death zone around SGR 1806-20 is staggering. Within 10 light years, the flare would destroy a planet's ozone layer and trigger mass extinction. At half the Earth-Moon distance, about 190,000 kilometers, the magnetic field would be strong enough to erase every credit card on the planet. At 3,000 kilometers, it would pull every atom in a human body into elongated, needle-like formations. The density is so extreme that a sugar cube-sized piece of the star weighs 100 million tons. Gravity at the surface is 200 billion times stronger than Earth's. And here's what makes it worse. This wasn't a supernova. This wasn't a star dying. This was a crack in the crust, a structural failure in a dead star surface, releasing energy equivalent to hundreds of thousands of years of solar output in a fraction of a second. Magnetars are corpses of massive stars, remnants left behind after supernova explosions, and they're so unstable that their surface can fracture and produce galaxy-scale explosions decades or centuries after the star's death. SGR 1806-2O is the most violent single event ever recorded by human instruments, and it happened because a star 20 kilometers wide got a crack in its surface. A dead star with a magnetic field a quadrillion times Earth's that can affect our planet from 50,000 light years away. But at least the magnetar stays in one place. The next object is spinning so fast it's on the edge of tearing itself apart. The spinner, PSRJ 1748-2446 AD, sits roughly 18,000 to 28,000 light years away in a globular cluster called Terzan 5, and it holds a record for the fastest spinning object ever discovered. It completes 716 full rotations every single second. That's 42,981 revolutions per minute, and at that speed, physics starts breaking down. The pulsar is a neutron star, approximately 15 kilometers in diameter, smaller than most cities, but it's heavier than the sun, packed into a sphere you could drive across in 10 minutes. The density is about 4 times 10 to the 17th kilograms per cubic meter. That's 50 trillion times denser than lead. A teaspoon of material from this star weighs 2 billion tons, roughly the mass of Mount Everest. And that impossibly dense ball of nuclear matter is spinning 716 times per second. Here's where it gets truly insane. At 15 kilometers radius, spinning 716 times per second, the equatorial surface velocity reaches 70,000 kilometers per second. That's 24% the speed of light, 1/4 light speed. At those velocities, relativistic effects become significant. Time dilation, length contraction, the works. The star is spinning at 94% of the theoretical breakup frequency. Spin it any faster and centrifugal forces would literally tear it apart. PSRJ 1748-2446 AD, is at the absolute physical limit of how fast matter can rotate before self-destructing. Surface gravity is 200 billion times stronger than Earth's. If you could somehow stand on the surface, you wouldn't stand. You'd be crushed into a film of atoms spread evenly around the star, no more than 1 atom thick. And because the star is spinning so fast, every star in the sky would cross the heavens from horizon to horizon in less than 1,000th of a second. The entire night sky would be a blur of light wrapping around you 716 times per second before you were atomized. The star wasn't born spinning this fast. It was recycled. Over billions of years, it accreted material from a companion star, a bloated star about 0.14 solar masses orbiting every 26 hours. As material fell onto the neutron star, it transferred angular momentum, spinning the pulsar faster and faster until it reached this ludicrous rotation rate. And now it's slowly evaporating that companion, cannibalizing the star that gave it this speed. Astronomers discovered PSRJ 1748-2446 AD in 2004 using the Green Bank telescope, and the moment they measured its rotation period at 1.396 milliseconds, they knew they'd found something at the edge of physics. This isn't a black hole warping spacetime. This isn't a magnet or with impossible magnetic fields. This is a ball of nuclear matter 15 kilometers across, spinning so fast its surface approaches light speed, existing right at the knife's edge where the laws of physics say it should fly apart but somehow doesn't. It's the most extreme object in terms of raw rotational physics, but rotation is nothing compared to gravity. And the final location has so much gravity it breaks the universe. The abyss. Toan 618 sits 10.8 billion light years away, and it's one of the most massive objects in the known universe. It's a black hole containing 66 billion solar masses, though some estimates using different spectral lines put it at 40.7 billion. Either way, it's heavier than every star in the Milky Way galaxy combined. The event horizon, the point of no return, stretches 2,600 astronomical units across. That's 390 billion kilometers, more than 40 times the distance from the Sun to Neptune. If you place Toan 618 where our Sun is, the event horizon would swallow everything out to the Kuiper Belt and beyond. The quasar surrounding Toan 618 shines at 140 trillion times the Sun's luminosity, so bright it completely drowns out its host galaxy. The galaxy is invisible from Earth because the supermassive black hole feeding at its center outshines every star. Gas spiraling into the accretion disk reaches speeds of 10,500 kilometers per second, and the Lyman Alpha Nebula surrounding the system stretches 330,000 light years across. That's twice the diameter of the entire Milky Way. But Toan 618 might not even be the biggest. Phoenix A, located 5.8 to 8.6 billion light years away in the Phoenix cluster, potentially contains 100 billion solar masses. Its event horizon spans roughly 3,900 astronomical units, about 590 billion kilometers, 100 times the Sun to Pluto distance. A beam of light would take 71 days and 14 hours to circle the event horizon. Researchers at Yale have proposed that Phoenix A may sit at or near the theoretical maximum possible mass for a black hole. We may have already found the biggest black hole that can ever exist. Here's what makes these objects uniquely terrifying. For a stellar mass black hole, roughly 10 solar masses, you'd be spaghettified at about 1,200 kilometers from the event horizon. The tidal force between your head and feet would reach 6 million times Earth's gravity. You'd be stretched vertically and squeezed horizontally into a strand of subatomic particles long before crossing the point of no return. But for Phoenix A, the math inverts into something more disturbing. The tidal forces at its event horizon are essentially zero. You would cross the point of no return without feeling anything at all. No alarm, no sensation, no physical indication that you've just entered a region from which nothing, not light, not information, not you, can ever escape. From an outside observer's perspective, your image would slow, redden, dim, and appear to freeze at the event horizon for eternity. From your perspective, you'd cross infinite times and eventually be spaghettified closer to the singularity. Every direction in space-time inside the event horizon points inward. Moving toward the singularity becomes as inevitable as moving forward in time. That's the horror. Not the violence, but the silence. An object so massive it's larger than our solar system, heavier than galaxies, possibly at the physical limit of what can exist. And the bigger the black hole, the gentler the crossing. You wouldn't even know you were doomed until it was far, far too late. If you enjoyed this video and want to see more, click the video on the screen now.